Jai Hind everyone. Today we are going to discuss the tries, or we can say trees, and it is a kind of data structure, or we can say it is a kind of advanced data structure. So first take a little introduction of that. So whatever we are going to do in this lecture is that we are going to explore the idea, implementation and application of trie data structure. Now whatever this trie data structure is, we are going to discuss that and how we can implement that and what are the applications of this data structures are, or we can say how we can implement or use this particular data structure in our real life applications. So let's take a look at what is trie. So if we are going to talk about the trie, this word trie or the name trie, it comes from retrieval. So this data structure is basically used for the retrieval. So from that word we are just taking the name trie. Now based on the application of, or based on the pronunciation of this trie, we can just call it as trie, or some other users say it as tree. Now we can call it a trie, and as well as we can call it a tree. Now what it is basically is that this is the character by character set of string implementation. Now let's understand what is the meaning of this character by character set of string implementation. Now whenever we are going to store a particular string, we generally use a certain kind of data structure. Sometimes it is a kind of array of characters, or we are using the linked list, or such kind of data structures we are using. Now in those, what we generally do, we store a complete string in a data structure, or we can say a character array. But in this tries, what we are going to do, we are going to create certain nodes, and we will keep a single character in that node. So we are going to implement this by using character by character sequence. So and the nodes which are going to store the keys, they will have certain parts, like we are storing the character, as well as we are having the certain pointer fields for the left child or right child or whatever it is. We are going to discuss that. So just take a example. Here we are having three kind of structures. So the first one is your binary search tree, and the second one is your trie. Now if I am going to just talk about this binary search tree, here we are having certain nodes in which the complete string is available. So either we are talking about the pair, or we are talking about the aqua, or we are talking about the part. So this particular node is having the complete string. Now on the contrary, we are having the second structure, that is trie. Now if we are just looking at this particular structure, it is also looking as the tree kind of structure. But what we are having here, this complete binary search tree is stored in this form in trie. Now if we are going to search for pair, here we will find out the pair at the root. If we are going to search for aqua, we will find out the aqua on the left side of the pair, and so on. So whatever string we want to find out, we will find out the complete string. And if we are looking at the way we are storing the data here, we are storing the complete string in a node. But if we are looking at this trie, in this trie, what we are having, we are having the first node, which is an empty node, or we can say we are not having any particular value in this node. So this is your root node. Now here each node is having only one character. Likewise, we are having A here, Q here, U here, and A here. And here also we are having only single character in each node. Now what is the use of such kind of mechanism we are using? So basically, as we have discussed, that the main use of this trie is for the retrieval of the data. Now where we are going to use certain kind of strings or certain kind of data in our database or in data storage, we can use this trie data structure for the storage. Now if we are going to search for particular data, let's suppose we are going to search for dad. Now we will have first D here, then A here, and then again D here. Now if we are going to search for data, then we will go for D here, A here. Now from this A, we are having basically three choices. One is for D, T, and Y. So we will go for T here, and then we will go for A here. So basically, as you can see that here we are just keeping the common subscripts or the common prefixes of a particular data and certain places, and when we are having some multiple branches from that common string, we are storing that data like that. Now we are going to just take an example of this trie data structure. Let's suppose we are having this kind of data. We are having certain name of the persons, and these are the ages of those persons, like Ramesh is of 56 years, Rakesh is of 23 years, and so on. Now again, what we will have? We will have a key value pair here. Now this, whatever data we are storing in this trie, it can be in the form of key or it can be in the form of key value pair, where the name of the person here is the key and this 56 is the value. Now what we are going to do? We will store this data in the trie. Now here we can just take a look here in Ramesh and Rakesh. So what tries allows, basically it allows to share the prefixes which are common among the keys. Now in this Rakesh and Ramesh, this RA is common. So since RA is common, we can have the same storage for RA, and from there we can have different storages for the distinguished substrings. And at the last of this particular key, after storing the complete key, then we can have two things. The first thing is null character, which will represent the end of the key. So this null value will be in your last node, the final node, and also it will contain the value. If the value is provided, the last node will contain the value. So just take a look here how we are going to store this Ramesh 56 in the trie. So this is your level 0, the root node, in which we are not having any character or any value, and this root node is having a link to another node, the second node, that is having the value R. So the root node is at level 0 and R is at level 1, and after that we are having A and M and so on. So these are the different nodes, distinguished nodes. So A is a different node, M is a different node, E is a different node, S is a different node, and similarly H is also a different node. Now this will be the final node. Now in this final node we are having two things. The first thing is this null character, which is representing the end of the key value, and the second thing is this 56, which is representing the value we are having with this key. So as we have discussed, this last node can have null character, or it can also have value which is associated for that particular key. Now we are going to add Rakesh here. Now in this we are having this kind of structure. So here, and when we talk about the Rakesh and Ramesh, we are having this RA common. So instead of creating a different node, we will utilize the common node which is already available here. Now so R is available here, A is available here. Now after that what we are going to do, we will add K. So after this A, we will have two branches, we can say, or we can say in the terminology of tree, the A can have two children, one is M and another is K. Now from there we can store E, S, H in different nodes. So if in this kind of implementation, if we are going to search for Ramesh, then we will start from this point, and if we are going to search for Rakesh, again we will start from this point. And since RA is common in both Ramesh and Rakesh, so first we will go here, and then we will go here, and after that whatever we are having, either we are searching for Ramesh or Rakesh. So let's say we are searching for Rakesh, then first we will check for this. If it is equals to K, no, it is not equals to K, then we will switch to this K, and we find out that this is equals to K, and then we will proceed. So we are having different levels, each node is available at different level, and those levels are defined as per their depth. Now we are going to add some more names in this particular tree. For example, after Rakesh, what we are having? First we have stored Rakesh, then we are going Ramesh, then we have stored Rakesh, then let's say we are having Ranjit. Okay. So in Rakesh, Ramesh and Ranjit, RA is common. This RA is common in all three. So in that way, after A, we will either go to M or K or N. We will go to M for Ramesh, we will go to K for Rakesh, and we will go to N for Ranjit. Now, the another name is, let's say, this Manish. Now, we are talking about this Manish. Manish is, there is nothing common in Rakesh or Manish. So, we are not having any common prefix here. So, that is why we will add a separate node for this M here. Likewise, we are inserting up, or we are creating a separate node where we are having distinguished value. So, similarly here we are having distinguished value. So, we are just adding M here. Now, after that we will insert this Manish. So, first we have inserted Ramesh, then we have inserted Rakesh, then Ranjit, then Manish, and after Manish, let's say we are adding Manoj. Now, while we are adding Manoj, so we can see that MAN is common in Manoj and Manish. So, we will just utilize this simple trail of the data which is already available here, and we will go till N, and after that we will create a separate node for O, and we will store Manoj in this way. So, if we are going to find out Manoj, we will find out Manoj in this way. Now, whatever value we are having for Manoj, we will store it here. Now, after that, if we are going to add Suraj, we are going to add Suraj here. So, Suraj, there is nothing which is common between the data which is already stored in this trie and the new string we are going to add here. So, new string is Suraj and there is nothing common. So, what we will do? We will assign a different node for S and then we will store this Suraj like that. So, these are the some operations of this trie. The first operation is add. So, basically we are adding a new data with a string key in trie. So, whatever we have done here, we are adding a new data. Either we are adding Rakesh or Ramesh or Ranjit or Suraj or whatever data we are adding, we are just doing this operation. Now, there is another operation, that is member. As we are using this data structure for the retrieval purpose, this is member operation is very much important here. So, what basically we are doing here? We are searching the trie for a certain key. Now, this key is available in this trie or not. If this key is available in this trie, this is member method will return true, and if this key is not available in this trie, then this will return false. Now, we can also do certain modifications. So, suppose we are going to do update operation. So, first we have to find out where the key is available, and after that we can just modify that. And the another operation is remove operation. So, if we want to remove some key from the trie, we can remove that also. So, that operation we have discussed here. In this we are going to discuss the is member operation. So, in is member operation we are having two parameters. The first one is trie and another one is key. So, trie is the whatever the data structure we are having, and the key for which we are going to search the trie. So, first thing what we are going to do, the first step, we will search the top level for the node which matches the first character in the key. So, let's suppose in this we are going to search for, let's say, Suraj. So, at the top level, we are having three nodes. although we can say this is the top label, root label, but after that the label at which we are having valid data is this label 1. So at this label 1 we will search for the character and we will match the character with the first character of the string which we are going to search. So suppose we are going to search Suraj, then first we will check for here R, whether R is equals to S or not, or then we will check whether M is equals to S or not, then we will check whether S is equals to S or not. So here we will find our match, then we can just carry on. Now after that, if there is no match, if there is no such character available at the top level which matches the first character of the key, then we simply return false. And if the matched character is null character, that means we have found the string in that particular try and we will return true. And if both conditions are not true, then we will go to the else part and we will move the subtree that match this character advance to next character in the key. So we will go for the next key and then we will go to step 1 and again whatever top label we are having, we will search for the first character of the subtree which is due to be checked. Now in this we are having a different example here, and this example is actually showing the try implementation. Now in the previous example, if we are looking here, we cannot actually identify that how we are implementing and what is, or we can say what is the pointer relation of a particular node to another node. Now in this diagram we can just visualize easily that what will be the pointer relation. So suppose so this is our data. For that data, what we are having, first we are having ME56. Now this is our root node. So first we are storing ME. Now whenever we are implementing try, a particular node in try usually follows the, we can say, left child right sibling mechanism. So every node will have the address of one of its children and every node also will have the address of its right sibling. So in that way, by using this mechanism, we can have the characters which are not matching at the same level. So suppose we are having this ME and we are storing this ME in this way, like we are having A, then M, then Y. Then we are storing this A and N. Then A is common between, this A is common between N and ME both. So we will go to the next level. Now at next level, we are already having M, and what we have to do? We have to add this N, and M is not equals to N. So what we will do? We will add a new node at this level and we will store N and that. And after that, the next N will be stored in the children of this particular node N, and at last we will store the the null character and the value for this N. Similarly, we will store this Emma. So we can say that, we can see in ME, N, we are going to take these two a single unit, and then this Emma and Rob and Rogers. So in Emma and Rob there is nothing which is common. In Emma and Roger there is nothing which is common. Similarly, we can compare Emma with Annie and ME and N. So we can say that A, E, R, they are at the same level. So if we are going to search for Annie, like we are going to search for Rob, so first we will go to this node, we will check here whether this A is equals to R or not. If it is not, then at the same level we will find out another node in which we will again make a comparison and we will do whether this E is equal to R or not, and similarly we will go to another character and whether this R is equals to R or not. Here we will find our match. Now in this, if we are applying is member try N, so what we are doing, we are going to find out this n in this try, then this method will return true as we are having n here. And in second, what we will do, if we are going to find out n in this try, then it will return false, because we are having n, the comparison will go till here, and after that in this try we are having null, but there is a character which is left to be checked, so it will return false. So this is how basically the try is implemented. So whatever implementation we are doing, we are going to discuss the structure of try. So first we are going to just look at the visual representation of a try node. So in a try node, what we are having 4 fields basically. The one is key, another is value, whatever key we are having. So if there is a key, we will store the key, or if it is the final node, we will store null here, and the value which is associated with that particular key. Then we are having a child, a pointer to child, and we are having a pointer to next. So we can say this next as the right sibling also, and this child is as left children also, and this key is basically key character, a single character from the key. So we are going to discuss the structure which can be defined a node for this try. So for key value pair, the structure of the node can be defined as what we are having. We are in this struct, we are having a key that is of type char, then we are having a value which is of type try value t. Now whatever the try value t may be, and then we are having 2 pointer variables, one is next and another is child, and the root node can be defined as this try RT structure, where we are just defining only single pointer value which is storing a node or a particular address which is pointing to a certain data structure which is of try node t, which is this, the node of the try. So this is how we can just create a node of the try and root of the try. Now what are the applications of this try data structure? Now as this try data structure is basically introduced for the data retrieval, where now just take a look at this example. Now here we are not storing Amy, Ann, Emma, Rob, Roger totally differently. There are certain things which are common here. So it can save us the energy of the retrieval, and it can also save the memory space. So if there is a duplicacy or more duplicacy, then this data structure is very much compatible for the implementation. So the applications of this tries are, we are having word matching and then prefix matching. So if the text is already pre-processed, it will take order of m times to search a particular word in this try. Now if we are going to use another data structure, that may take a different amount of time based on the how many words we are having, but in this try the maximum amount of time will depend on the length of the word. So here we are having a certain example where we are having certain strings. This is a certain string. Here what we are having, we are just picking certain words from this particular string. So where we are, wherever we are having a white space, based on that white space we are separating these particular words. Now we are just also taking a word which is having more than 2 characters, so we are going to store that. So this is our root node. Now if I am going to see this SEE, where it is, so we are having this S here, then E here, and then E here. Now what are the occurrences? These values are representing the occurrences of this C in this particular text. So this C is occurring at index 0 and it is also occurring at index 24. And just take up the word by. If we are going to take this word by, so from this root node we will have B here, then we will have U here and Y here, and the value which is associated to this by is 36, which indicates that it is available at index 36. So in this way we can store all the strings or all the words available in this text, and we can search each and every word which is available in this text by using this try in order of m time, which is very much less than the total length of this string. So we can also use these try data structures are very much important for the string matching, word matching, prefix matching, or basically the data retrieval kind of operations. So that's it from this lecture. In next lecture we will meet again. So thank you very much.